All right, today let's work a couple of these force centripetal problems to get you started. I'll work the first one first because it'll give us an idea about what centripetal force is, and then I'll work a little tougher problem next. But the easiest way to think of centripetal force is being the sum of the forces inward. So if we think of Fc as being Fg plus Fn, the normal force, and gravity, it makes it easier for us to understand what's going on, and in the end I'll show you how this makes sense. Number one just wants a motion map. Notice I've drawn the acceleration inward and the velocity I kept constant. I'm not too worried about those motion maps. Number two, it says, is it accelerating? And the answer is yes, it's accelerating. It's accelerating inward. Is it moving at a constant velocity? Yes. Is it accelerating? Yes. The acceleration is toward the center. So this is that whole x, y independent of each other. It's accelerating in the y direction, but moving at a constant velocity in the x direction. We need to remember that. So if we draw our force diagram, here's our object. We got F normal, the normal force, Fg, gravity, and Fc is going to be the sum of those two things. Then it gives us the math that says, okay, let's work the problem. So we have, first problem it gives you is it gives you the speed in kilometers per hour. So right away I went and changed that because we can't use kilometers per hour. So I multiplied kilometers per hour. In 1 hour, there's 3,600 seconds, so the hours go away and leaves us seconds. And in kilometer, in 1 kilometer, there's 1,000 meters, so our kilometers go away. And we're left with meters per second, which is what we wanted, is 12 meters per second. Then it's just a matter of plugging it into the formula. 1,200 times 12 squared divided by 25, and we get 6,900 newtons. Now what does this mean though? This is the physics in the problem. All right? If we go back to our force diagram, and we said that Fc equals 6,900, Fg, given 1,200 kilogram mass, is 12,000 newtons. Fn then leaves us 5,100 newtons because Fc, these are in opposite directions, so 1,200 minus 5,100 must equal 6,900. And then this seems to make sense to us because you should feel like you weigh 12,000 newtons. But because you're going over the hill, you've all experienced that upward sensation when you're going over the top of a hill. Your normal force is less. If you were sitting on a scale in this car, you would weigh slightly less when you got to the top of the hill. This is what these sorts of problems teach us.